All right, we're going to discuss implicitly defined functions. There is a relation. Now, a relation is not a function and it doesn't pass the vertical line test, but there is a very famous relation that we use in trig a lot, and that happens to be the unit circle. So I'm going to write down the unit circle. And the rectangular equation for that, and remembering that's a circle with a radius of 1, The equation for that is x squared plus y squared equals 1. And I think everybody can agree pretty easily that a circle does not pass the vertical line test. However, a circle has two functions embedded in it, in disguise, so to speak. And those two functions are implied with this equation that we call x squared plus y squared equals 1. Now, if we were to put on our calculator this equation, we'd have to change it to a form that is in y equals, because if you go to the graphing part of our calculator, you have to type in y equals. And here I can't type it in because it's x squared plus y squared equals 1. It's not explicitly defined as a function of x, meaning it's not y equals. So let's solve this equation for y. All right, in order to do that, we would move the x squared over and we get y squared equals 1 minus x squared. And we have to take one more step and we would say y equals the square root of 1 minus x squared. But it also could equal y equals negative square root of 1 minus x squared, because we have to take into account the plus or the minus. Now, y equals the square root of 1 minus x squared is always positive, which means that this equation here represents the upper half of the unit circle. And the upper half of the unit circle, if you consider it all by itself, y equals the square root of 1 minus x squared, is a function. And then the bottom half of the unit circle, y equals negative square root of 1 minus x squared. The bottom half is in and of itself a function, and it passes the vertical line test. So inside this equation, x squared plus y squared equal 1, are two implied functions. Just waiting to be found. Now, don't take just my word for it. We can go to Desmos, which everyone loves, and we can actually type in the implicitly defined relation. We can type in x to the second plus y to the second equals 1. And there's our unit circle. I'll make it so that we can see it here. Here's our unit circle with a radius of 1. And then we can type in our two implied functions that we solve for. We can say y equals the square root of 1 minus x to the second. And you'll notice right away that that is the upper part that's green here. And we'll make this one red up here so we can see the difference better. And the bottom part would be, if I were to copy and paste this, and put a negative here, and you see that the bottom part is indeed the negative part. And so if I were to take away the relation, and you can see if I take away one of them, that this indeed is a function because it passes a vertical line test all by itself, and then the bottom half would pass the vertical line test all by itself. So the plus and minus square roots are the implied functions inside of the unit circle equation up here, which is x squared plus y squared equals 1. All right, well, let's do a more fun equation. which is a lemniscate. Now, we'll figure out what a lemniscate looks like in a minute. But we're going to do the same thing here, and we're going to solve for y. And I'm going to distribute first. So we'll say x to the fourth minus 10x squared plus 10y squared, distributing that pesky negative, equals 0. 10y squared equals 10x squared minus x to the fourth, if I move these two terms to the other side. And y squared equals 10x squared, pardon me, 10x squared minus x to the fourth, all divided by 10. And then solving for y, we're going to take the square root of both sides, and we'll get y equals the square root of 10x squared minus x to the fourth divided by 10. Or we'll get the negative one, which is y equals negative square root of 10x squared minus x to the fourth all over 10. And these would be the two implied functions inside this implicitly written relation. And now let's go to Desmos and see what this thing looks like. The lemniscate is going to be x to the fourth. Oops, I got to the second there, to the fourth, minus 10 times parentheses x to the second minus y to the second equals 0. Oops. Helps if I pay attention to what I'm typing. Those parentheses equals 0. Wow, and there's our lemniscate. A lemniscate is what we are familiar with is a infinity symbol. So lemniscate is a fancy word for our infinity symbol. And then the two implied functions that we found inside that original equation is going to be the square root of, and I'm going to put in the numerator here, 10x to the second minus 10, x to the fourth. Close the parentheses, divided by 10. You notice that that's the top half here in green. And I'm going to do some copying and pasting, and we're going to make this one a negative. And you see the bottom half. If you'll notice that this first equation here, y equals the positive square root, is always the upper half here because the y's are positive above the x-axis. And the negative square root always applies to the one that's underneath the x-axis. So that's the piece that's underneath. And both of them individually, again, are functions. All right, so let's do the next one, which is the trident of Newton. And I think everybody knows perhaps that Poseidon or Neptune carries a trident, so it looks something like that. So we're going to be on the hunt for that when we go to Desmos to see what it looks like. Now this one is implicitly defined, and we need to solve again for y to see if we can find the implied function. And so we're going to say solve for y. And we're going to get y on one side by itself. Now this is a one-step solution here because all I have to do is divide both sides of the equation by by x. So this is y equals 0.1x to the third minus 2x squared minus 3x minus 4, all divided by x. And you'll notice the previous two that we did had two solutions because they had a y squared here. And this one has one implied function because it has only the y. So it has one implied function. All right, so let's see what that one looks like. The trident of Newton. Okay, so it's going to be x times y equals 1x to the third minus 2x to the second minus 3x minus 4. All right, and we can't see it right away. I'm going to make these So undone here so we can see it. All right, so there it is. And you might say, well, I don't know if that looks like a trident, Mrs. Muller, but if you scroll in enough, you see if we get far enough out, you can see the trident appearing. So this would be the first prong, the second prong, and the third prong. And there's the, the staff. So kind of interesting. And they call it the trident of Newton because it looks like a trident. And then Newton was very famous for working with these kind of equations. So kind of has his name attached. So let's do the parentheses. I want to get rid of the square root. We'll start all the way over here and get rid of the whole thing. Sorry, I'm slow typer, but okay, parentheses, 0.1. Well, actually, I can copy and paste this from the top here. So we'll copy this, paste it here, and then we'll divide by x. And it should, oh, it helps if I put the color in there. Do you see how that matches identically? And this one here, we don't need at all because we only have one implied function inside this implicitly defined function. All right, let's try another one. Now this, pronouncing this guy's equation is quite interesting, and I think it's Tschirnhaus. Tschirnhaus is cubic. All right, so we're going to solve this one for y because this is explicitly defined because it's not explicitly solved for y. And we're going to get y all by itself. So we're going to say y squared equals x times x minus 1 squared divided by 3. And then we're going to take the square root of both sides and we'll get a positive root. Or another equation would be the negative root. All right, so those are our two implied functions. And you'll notice if I wanted to simplify this, do you see how this is a perfect square under a square root? Well, the solution to y squared equals x is y equals the absolute value of x if you were to solve that. And so we need to pull this out with an absolute value. So this would be y equals the absolute value of x minus 1 times the square root of x over 3. Or y equals negative absolute value of x minus 1 times the square root of x divided by 3. So you could pull the x minus 1 out of here if you use absolute value bars. All right, so let's see what this Tschirnhaus's cubic looks like. All right, that's going to be 3y to the second equals x times x minus 1 quantity squared. And I'm going to zoom in on this because it's interesting when it gets smaller and we can zoom in, just because it has a little loop down here. And you can see how this implicitly defined equation here is not a function, it's a relation. And so it's going to have an upper half and a lower half, and those are going to be like we found here, which I can take the square root of parentheses x times x minus 1 to the second, close the parentheses, divided by 3. And you see how that's the upper half, and we can do the lower half of making it negative. Make that dashed. And there it is. We have two implied functions in this one. Now let's see if I use the absolute value bars, if you can buy whether they're the same. So that would be y equals, let's try this, absolute value of x minus 1 times the square root of x divided by 3. Look at that, it matches. So when you take the x minus 1 quantity squared and you take the square root of it, oops, I'm sorry. I need to go back and show you something real quick. What I meant to say is y equals the square root of x squared is equal to the absolute value of x. Sometimes I'm a little bit dyslexic and I got that backwards. So this is the important factoid there. So if you take the square root of something squared, then it's going to be the absolute value of x. In practice, I did it right here, but you know, the algebra back there was not correct, so I needed to fix that. So y equals negative, control paste. Oh, and I got too many. Y equals here. There we go, and it matches when we pull the absolute value out. So, so that looks good. Chern-Haas's cubic with two functions that are implied in this equation up here. All right, let's move on and try another one. See how these aren't too bad. All right, next one is Newton's diverging parabolas. Another equation that Newton worked with. So we're going to take this and we're going to solve for y. And to do that, we're going to go divide by 4. So we're going to get y squared is equal to x times x squared minus 2x minus 10, all divided by 4. And then y is going to equal the square root of x times x squared minus 2x minus 10 over 4, or y will equal the negative of the square root of the same thing. Now we can simplify this a step because we have a perfect square in the denominator here, so we could make this the square root of on top x times x squared minus 2x minus 10 over 2, and the same thing over here. We like to eliminate all the square roots that we can, if possible. And those are the two implied functions inside this equation up here. So let's look and see what Newton's diverging parabolas look like. That would be 4y to the second equals x times x to the second minus 2x minus 10. And I'm going to get rid of all of these. And zoom in here so we can actually see what their diverging parabolas. So this side looks kind of like a parabola, but this one doesn't. And I'm not sure why they called them diverging parabolas, but that's what the names of the curves are. So let's write down what our two functions are. That would be square root of x times underneath x to the second minus 2x minus 10. And then we're going to go outside the square root and divide by 2. And you see how that's the top half of the diverging parabolas? And let's change the color here. And we'll make it blue and dashed. All right, and then we're going to make it negative, this equation, because then that'll be the bottom half. And we'll change that one's color. I guess we'll make it black and dashed so we can see that they absolutely match. All right, so implicitly defined functions are functions that are implied inside of other equations that are not explicitly solved for y. Equation, if you can solve for y, and then it's a function passing the vertical line test, then you have an implied function inside that equation. And so that is, in a nutshell, implicitly defined functions. So we'll see you later.